It's not just some crazy fringe idea anymore. Turning plastic into fuel is something that's actually being done in labs and on an industrial scale, too. You might have even seen headlines about this in recent months, like these from Fox News and Interesting Engineering. Or maybe you read an article from the New York Post about how this innovation could save us from our dependence on foreign oil. Yeah, turning plastic into fuel is a thing. And today we're gonna dive into how it works, what kind of fuel you can get out of it, and why it's so controversial. If you didn't know that this was even possible, you're not alone. But don't worry, we're gonna break it down for you right now. First off, let's talk about how it's done. There are a few different methods, but here are the top 3. No, one is pyrolysis, which is also the most common method. In simple terms, they take shredded plastic, heat it up to between 350 and 500 degrees Celsius, and doesn't have any oxygen around. This breaks down the long polymer chains into shorter hydrocarbons. The result is a mixture of liquids, gases, and a solid char, or coke. The liquid can be refined to make things like gasoline, diesel, and kerosene. And the flammable gas can be used to power the reactor itself or create even more liquid fuel. The char isn't much used as fuel, but it can be used in cement kilns or for making steel. The second method is gasification. Here, plastic waste is converted into something called syngas, which is mainly composed of carbon monoxide and hydrogen. This happens at very high temperatures with limited amounts of oxygen or steam. The syngas can be burned directly for energy or turned into liquid fuels, using a process called the Fischer-Tropsch process. And third is depolymerization, which literally means breaking the polymers back into their original monomers. To do this, you can use either heat or chemicals or both. Some of these monomers can then be refined to produce usable fuels. Okay, great, but what kind of fuel are we talking about exactly? So far, the most common type of fuel produced is a diesel-like oil. But don't worry, we've got you covered. You can also get gasoline fractions, although those need refining. And it's even possible to create jet fuel range hydrocarbons. Also, don't forget the gas that's produced during pyrolysis, which can sometimes be used as a natural gas substitute. So what are the advantages of this technology? Well, there are quite a few. First, it helps tackle the massive global plastic waste problem by giving it a useful new purpose. Second, it creates fuel out of materials that would otherwise probably end up in landfills or the ocean. Third, it can be done on a small